As the 18th century moved into the 19th, it was a great time of change. There were revolutions. The French Revolution and the American Revolution are the ones we know best. But of course, the foundation of Australia happened about the same time. There were revolutions in South America because previously there had been Spanish and Portuguese colonies, and they became free and started to fight one another. The British, of course, were always open to trade, being a nation of shopkeepers. The Royal Navy was now not occupied by the Napoleonic War, and they found time to inquire into the possibilities of trade. The British government decided that 6 ships should be appointed to looking at the conditions, anchorages and harbours around South America and to some extent around Africa. 3 of them were Chanticleer, Barracuda and Beagle. And of course it's always Beagle that we hear about. The captain of Beagle was Robert Fitzroy. He'd had an unfortunate experience in the first voyage of the Beagle when his commander, Captain Stokes, committed suicide while they were in the Tierra del Fuego. This affected Fitzroy, who became the commander, very seriously because his family had a tendency to depression. So when Darwin was appointed to Beagle, he went first as a naturalist, a scientist as we would call him now, but he also went as a companion to Captain Fitzroy. This was necessary because Fitzroy couldn't talk to his officers as equals. They were definitely not. But he could talk to Darwin as an equal, since they came from actually rather divergent backgrounds, but they were socially equals. Because the bicentenary of Darwin is just coming up in February in 2009, I thought it was worthwhile doing a survey of the instruments that the Beagle carried. She carried 2 sets of instruments, those for normal navigation of the ship, of course, but also survey instruments. And I've managed to assemble some or all of these instruments so that we can have a look at them. This is the trophy room of the Hobart Reel Tennis Club. This building was built in 1831. And that was about 4 years before the Beagle arrived in Sullivan's Cove, just down there, about 5 minutes walk away. Admiral Francis Beaufort was the hydrographer to the Royal Navy. He was a most meticulous man who'd spent all his life making maps. So when he equipped the Beagle and the other ships with their instruments, they were the best that could be found. There are really 4 instruments which you use when navigating a ship. The first one is the chronometer, the second one the sextant, the third one the compass, and the 4th one the log and line. The chronometer and the sextant together will give you your position on the Earth, because the sextant gives you latitude, the chronometer gives you longitude, the compass tells you in which direction you're going, and the log and line tells you how fast you're going. This chronometer was built in 1822 by William Heron of Greenock in Scotland. It's magnificently preserved, it's still going well, keeps good time, and has to be wound every 2 days. The case is made in 3 sections. The top lid reveals the clock inside there under glass. That would be quite sufficient for the navigator, but the captain or whoever is winding the clock would open the second part and turn the clock over to get to the winding hole, which is underneath. There's the winding hole. And here there's a little catch with which you can stop the gimbal working, so that the clock is now firmly fixed in its box. Normally we leave that open so that the clock can respond to the movements of the ship. Fitzroy had a man on the Beagle whose job it was to wind the 22 chronometers that he had on board. He had so many because he wanted to get the average as accurate as possible. 16 of them survived to get back to England. The chronometer actually works like this, that it keeps Greenwich time, so that you can tell the difference between noon at Greenwich and your local noon wherever you are on the Earth. Now, since 24 hours is equivalent to 360 degrees, then it's an easy conversion to give yourself your longitude. When they got back to London, the chronometers were discovered to be 33 seconds slow. Most people would have thought this was pretty good, but Fitzroy decided that this wasn't quite as accurate as he wanted, and he pondered for some time about where the error had arisen, and he put it down to what he called magnetic effects. Today we find ourselves on the sail training ship Lady Nelson. The Lady Nelson is a replica of HMS Lady Nelson, which was built in England in 1799, came out and served for many years in Australian waters. She was the settlement ship for the state of Tasmania when settling began in 1803. She was the smallest ship in the Royal Navy, and she had a nickname. She was called His Majesty's Tinderbox. We now have to look at the three navigational instruments that every ship of the time would have carried. The first is the magnetic compass, which gives us direction. The second is the sextant, which gives us, in combination with the chronometer, position. That is to say, latitude and longitude. And the third is the log and line, which gives us the speed of the ship through the water. The principle in which the compass operates was discovered by the Chinese some hundreds of years ago. It essentially measures the direction of the Earth's magnetic field, which is more or less north-south. It's possible to correct compass readings by observing the directions of sunrise or sunset. When the compass is installed in a binnacle on a ship, it gives us a direction in which the ship is moving. Well, this is the sextant. It's a wonderful instrument. Its job is to measure angles. And it does so because it has two mirrors so that you can see two objects in the same telescope. One of the objects might be a star or the sun and is reflected in the top mirror, and the bottom one you look through because it's half silvered and you can see the horizon through that. So the aim is to bring the sun down to the horizon, and then you measure off its altitude on the degree scale. Now, it's a wonderful instrument because you can hold it in your hand, and you could measure to 1/3 of a minute of arc, which more or less corresponds to 1/3 of a nautical mile in your calculations. We use it two ways. We use it for measuring latitude, and in this case we look at the sun at midday. We determine the point at which it's highest above the horizon, measure that angle, and then by reference to tables, which gives us the declination of the sun for every hour of the year, we can calculate our latitude. We do it much more accurately than the Norsemen, who used to do it by looking at the North Pole star, and they knew how far north or south they were. For longitude, it's a bit more difficult. You have to have the clock. You do the same thing. You determine the time at which the sun is highest over the horizon as it crosses your meridian at noon. And then the time on your clock, which is the time in Greenwich, and the time that you determine as noon, the difference between the two is your longitude. It's not quite as simple, and it took them hundreds of years to decide how to do that. It had to wait for the invention of the chronometer. This is called the index mirror. This one's called the horizon mirror. This is the telescope. And these are little shades. They're coloured glass because you can't look directly into the sun. And of course the scale here, you operate the handle here by moving the scale backwards and forwards, which turns the index mirror. The log is a piece of wood designed to remain still in the water. The line is marked out with knots, spaced out at 1/120th of a nautical mile, which is in fact 1 minute of latitude. Okay, everybody ready? Yep. I shall say go. Go. If we count the number of knots which run out while the sandglass measures half a minute, we now have measured the speed of the ship. Okay. There's a much cruder method called the Dutchman's log, which consists of throwing a piece of wood over the side and counting how long it takes to run the length of the ship from the bow to the stern. Obviously it's very inaccurate, but it is usable in people who are knowledgeable about the length of the ship. In Nelson's Navy, the log was run apparently every half hour, as they were very concerned about the speed of the ship and, of course, very interested in the navigation. The Beagle was unusual in that she had land surveying instruments on board. And this was because Fitzroy had to produce maps of the anchorages that he was surveying. And she used a process called triangulation, and it uses the properties of the triangle. Now the triangle is an interesting object. It has 3 angles at the corners and 3 sides. And the rule in mathematics is that if you know one side and 2 angles, you can uniquely define the triangle. And we use this in triangulation. What we do is to draw a baseline, which represents a baseline we measure on the ground. And this might be a kilometre or so long, possibly longer, depending on the scale that we're working. And we set up stations at either end, which we then occupy with a device for measuring the angles towards a third object, in this case B. So we then draw our diagram representing this with a baseline. We set up here. We look at a third object, which is probably the top of a hill. And we measure that angle between the direction of B and the direction of C. We then go down to C and we do the same thing again, the direction of A and the direction of B, and we measure that angle. We now have the 3 things that we need to uniquely define the triangle, because we have that length, we have that angle, we have that angle. So we can calculate the length of that side, the length of that side, and we can calculate that angle. you have uniquely defined the position of B, your distant point. We can now go on extending this because since we know the length of C, we haven't measured it, but we can calculate it. We go back to A, and there's a point over here, we'll call D, and we sight on D, and we draw that line, and we measure that angle. Then we go to B, we sight again on D, we draw that line, and we measure that angle. And we have now uniquely defined the position of D. And we can go on doing this to another point there. Oh, sorry, the noise. Another point there, and you then define the position of E. And you can go on doing this all day. And you set up a network of triangles, which is the basis of your survey. It defines all the hills, for instance, and you can then do detailed work round just to define where the shoreline is, and you have defined the shape of your anchorage. Fitzroy did this and gives us a diagram in his works of how he did it, and it's interesting to look at his particular diagram, and you'll see that it has these sorts of properties. Now, in order to define our triangles, we have to measure some angles, and the instrument we use is the Theodolite. This is a very ancient one. This is an antique. It was built between 1825 and 1850 by a firm called Troughton and Sims in London. The Beagle had an identical instrument on board, and Fitzroy spoke very highly of it. He called it his Troughton circle. We use it to measure angles between prominent points, which we want to include on our map of the anchorage. And the points are generally put on the tops of hills. So I'm going to show you how one measures the angle between 2 or 3 points. These are not necessarily all in the same triangle, but if you're building a framework of triangles, as I indicated on the drawing board, then they will come in to define the triangles in which they exist. So in order to measure the first angle, we have to line up on our first object, which is a hill over there. Someone would have to go up there and set up a station. We then line up on it, read the instrument, and note the reading. We then swing round to the next object, which we'll put on that hill over there. Similarly, we line it up. And again, we record the angle. And again, round to the next object, which would be a mark on that hill over there. And record the angle. The fact that these angles are not in the same triangle doesn't matter that much, because we'll have a framework of triangles, and having measured from this end of our baseline, we then go to the other end and record similarly what's called a round of triangles, a round of angles, and these will all come in useful when we come to draw our framework up accurately, because we'll be able to define each triangle uniquely from either a length and 2 sides, 2 angles, or some combination of 3 items from the triangle. And this was the sort of thing that Fitzroy was doing round each anchorage as he came to it. In fact, he did a similar survey for this particular anchorage, even though it was rather well known at the time. There are some instruments which were peculiar to the Beagle and exploring vessels, and this is one of them. This is the magnetic dip needle. When we were looking at the compass on the ship, we saw that it measured the direction of the magnetic field in a horizontal plane. This one is different in that it measures the magnetic field in the vertical plane, because the field, after all, is inclined. And this needle gives us the angle of inclination of the field. If you're close to the magnetic pole, which in our case is somewhere just off Antarctica, the direction of the field would be vertical. If you're somewhere near the magnetic equator, which is not far from the Earth's equator, then the needle would be horizontal. This was actually suggested at one time as an aid of navigation, but it's variable as the magnetic field of the Earth changes, and so really it's not much use for that purpose. There is another use for this instrument, and we can use it to measure the relative strength of the magnetic field. In this case, we have to disturb it with a magnet so that it swings. Then the speed of oscillation of the needle is a measure of the strength of the magnetic field. The slower it oscillates, the weaker the field which is pulling it. The faster it oscillates, the stronger the field. And you can use this to measure relative strengths of field in different places on the Earth. And they were done, for instance, between Paris and Southport in Tasmania on one particular occasion by a French expedition, and they used a dip needle rather like this. There's one instrument I want to mention that wasn't actually carried on the Beagle, but I mention it because it carries Robert Fitzroy's name. And that is this is the instrument here, the Fitzroy Barometer. He designed it about 20 years after the voyage of the Beagle, and it was designed to be installed at seaports to give fishermen and other seamen some warning of the coming weather. It's a mercury barometer, as I say, and the point about it is that it's the rise and fall of the barometer which actually predicts the coming weather. So these indicators would be set onto the barometer, and in passing hours you would easily see whether the barometer was rising or falling. And he gave you very good instructions here as to the meaning of these particular movements. The instrument wasn't just a barometer, it included a thermometer here, and this tube here, which was actually a weather glass. It contained a solution of camphor in alcohol, and I think there were other salts as well, ammonium nitrate and things like that. And the point about it was that it was supposed to go cloudy when cloudy weather was expected, and go clear when clear weather was expected. I don't think it actually ever worked, though you still see some Fitzroy barometers which have the chemicals in the tube. Fitzroy is very keen to make life safer for those who work on the sea. And he installed these round the British Isles and in other places in France to give warning to seamen who were going to sea. And he installed also a series of cones which would be hoisted on masts. A south-pointing cone meant that the weather was going to be coming up from the south, a north cone that it was going to be coming from the north, and there was an additional thing to tell you how long the weather was going to last. And by these means, he certainly made going to sea a lot safer. He subsequently was the head of the Meteorological Office, and the Meteorological Office honours him with the name of one of their forecast areas that used to be called Finisterre. It's now called Fitzroy. On the afternoon of the 5th of February 1836, the Beagle tacked her way up the Derwent estuary here and came to anchor in Sullivan's Cove on the other side of the river at about 5 o'clock. She was brought round the world this far, and indeed back to England, by the use of the instruments that we've examined. And she'd almost completed the survey work which the British government required her to do. Her passenger, Charles Darwin, realizing that he would have 10 days here in Hobart, spent the time mapping the geology of the two shores of the Derwent, the eastern and western shores, and made significant geological discoveries. One supposes that the ideas were beginning to form in his mind, which, after 20 years, he published as the great book, The Origin of Species by Natural Selection. And indeed, this book was so significant that it changed the whole science of biology and has also changed our view of life.